In this video, I will demonstrate how to generate a QSAR regression model in Forge using machine learning methods. In Forge, I have activity data for 377 ligands of the orexin 2 receptor. The ligand conformations have been optimised to low energy poses and the ligands have been aligned. Before running a regression model on this dataset, I need to partition the data. Having an external test set enables you to monitor the predictivity of the QSAR model in a realistic manner, and we recommend having at least 20 molecules in the external test set. I now need to select the machine learning method I'm going to use, or alternatively I can choose automatic, which means Forge runs all machine learning methods and uses the best one. Finally, I need to select the data I'm going to run the QSAR model on. The Ki nanomolar data are the only activity data for this set and thus have been correctly selected. The results of the model building calculation are presented in the QSAR model window, where we can see that Forge, after generating 4 different models, has selected the support vector machine model as the best for the dataset. The graph under the Activity tab shows predicted versus observed activity for all database molecules using the selected model. The fit of the data to the model is quantified in the R² value on each graph. The value for R² varies between 0, no better than guessing, and 1, perfect fit. Selecting points in the graph will select the corresponding ligands in the molecules table and make them visible in the 3D window. This model has a good R², however the ultimate arbiter of the quality of the model is how well it performs on molecules not involved in the model building in any way. The R² is also good for the test set, and this gives me confidence that the model has a real predictive ability, despite a few low active outliers, which are structurally quite different from the training set. The PCA plot, new in Forge 10.6, is useful to identify outliers and groupings in the 3D descriptor space, specifically those that differ in terms of electrostatics and shape from the other molecules in the training set. I may consider excluding these compounds from the model. See for yourself how Forge can aid your understanding of structure-activity relationships and assist with new molecule design. Contact us today to evaluate Forge.